Welcome, everyone. How's everybody doing tonight? Yeah. Enthusiasm. Can we try it again? How's everyone doing tonight? Right on. Hi. My name's Ben. I'm one of the co-directors of this Find Here conference series called Hopes 20, or Hopes. This is the 20th iteration of it. We're sort of at the tail end of our conference with two events left to go. One, this amazing lecture, and the next is the book launch, or sorry, not the book launch, the publication launch, the launch of Casisma, / our wrap-up party. I want to thank everybody for being here tonight and introduce Nataly Gattegno. She's the founding design partner of Future Cities Lab, an experimental design and research office with Jason and Kelly Johnson in San Francisco, California. Working in collaboration, they have produced a range of award-winning projects exploring the intersections of design with advanced fabrication technologies, robotics, responsive building systems, and public space. Future Cities Lab's work has been exhibited and published worldwide, most recently at the Yerba Buena Center for the Arts and at the SF MoMA. Nataly also works as an associate professor of architecture and chair of the graduate program in architecture at the California College of Arts in San Francisco. Let's all welcome Nataly with a warm round of applause.
Thanks. Thank you very much for the round of applause and the kind of energy increase in the room for the 7 p.m. lecture. It's been really, really fantastic being here for the day today. There's been a great series of talks, conversations, and panels. I want to thank the students for inviting me and organizing and orchestrating a pretty amazing event, and the school for hosting. It's been a really, really it's been really exciting to be part of this group of talks and conversations. I also think that the topic is also a very kind of important one and a very kind of timely one. I may have taken the prompt a little bit too seriously in this kind of introduction, the issue of inevitability. So you may need to bear with me a little bit, but I do firmly believe that we need to find ways, techniques as designers, as architects, landscape architects, planners, to thrive in this new environment. It's an environment that we know a lot about. We have a lot of information about how bad things are going or what we need to do about them, yet we're very, very kind of, let's say, slow or reticent to actually react to. So hopefully, I mean, I was just in the shaken and stirred or not stirred kind of panel prior to this, listening into the conversation. So I think this will kind of set a very kind of different counter to some of the conversations there, but also maybe kind of prompt you as students, as designers kind of moving out into the field next, to really maybe question the things that you may have taken for granted till now, and really kind of push the envelope of the education that you actually have received to now. So what is or who is Future Cities Lab? As was said, we are, what we would call an experimental design practice, operating at the intersection of art, architecture, technology, public space, and the environment. And I know those are really big catch-all kind of terms, but hopefully through the work you'll see a kind of broad spectrum of the kind of work that we do. We do projects that may involve maybe more interactive art, maybe more on the kind of public art installation scale, gallery installations, gallery exhibitions, sometimes speculative projects that we, let's say, invent entirely for ourselves, either through competitions or through design prompts that we receive, or in some cases collaborative projects where we're actually kind of consultants or collaborators within larger projects. And in those kind of projects, we basically take more of a consulting kind of role. So one of the things that I wanted to kind of set up a little bit in response to the prompt of inevitability that this kind of Hopes 20 conference sets up is that one of our interests, one of Future Cities Lab's interests, is exploring the relationship between the built and the natural world as one that is synchronous and full of opportunity, full of potential. We see the things that surround us as latent with potential, latent with opportunity that is up to us as designers to harness, up to us to take advantage of. It's stuff that's out there that we can use and leverage for design. I'm showing two examples from Hans Hock's work. In this case, the blue sail, which is a blue kind of sheet of fabric, a fan moving in the gallery throughout the entire day, and this kind of geometry, a simple kind of rectilinear sheet that is able to generate this kind of completely, let's say, kind of diverse set of forms as a result of an oscillating fan in a space that is perturbed by gallery visitors as they move through the gallery. This kind of back and forth between the built landscape and the things that surround us, the forces that surround us, whether those are natural forces, environmental, climatic, weather, circulation. Those are things that we can actually kind of take advantage of. This is probably one of my favorite quotes. Make something which experiences, reacts to its environment, changes, is non-stable. Make something indeterminate that always looks different, the shape of which cannot be predicted precisely. Make something that cannot perform without the assistance of its environment. Make something sensitive to light and temperature changes that is subject to air currents and depends in its functioning on the forces of gravity. Make something that lives in time and makes the spectator experience time. Articulate something natural. This is something Hans Hock wrote for this project of his, the condensation cube, which is literally an acrylic cube with a small amount of water in it, located in a gallery space. Depending on the amount of people that surround it and kind of circulate the space, condensation would form in the cube and in different locations and in different kind of areas within that cube, depending on the type of occupation that the space actually had identified. Key to this quote for me is the first word, make. Right? Make something, make something, make something, make something, right? It's about making, about leaving an imprint, about designing, about actually placing something out in the world and testing it with its kind of corollary. So a lot of the work that you guys will see today is kind of obviously made, and obviously with a kind of firm belief in making, but it also has a pretty kind of let's say a nod or a, let's say, belief that technology is going to exist around us. It's going to continue to exist around us. It's going to continue to be kind of a huge part of the lives of probably our children and your children and moving forward. The expectation that our surroundings actually speak to us, the expectation that our surroundings actually can respond, react, give information back to us about things that we may think we know or would like to know. So the inevitability isn't just an environmental one, but it's also a technological one. One of the things we try to do is explore that kind of intersection between kind of environment, technology, and public realm and the design. One of the things that I think is also equally important within this is that the forces that I'm talking about, the forces that surround us, yes, they're climactic, they're technological. I would also argue, and maybe the work, I would say that's where the work needs to kind of push a little bit further, if I can already add a self-critique in the lecture before I've even shown you any of our work. But the issue of, the other kinds of forces that surround us, the other kind of inevitable forces, be they political, cultural, social. That's something that's come up a lot in the panel conversations, in Joan's talk earlier today. The fact that it's not just about, let's say, a kind of pure set of data that you're inputting into a design, but there's other things in there that are maybe a little bit more ephemeral, that as designers we maybe have the capacity to kind of intuit and embed into our work. So one of the things that Future Cities Lab is really interested in exploring is that kind of relationship, right, between the built and the natural world, these kind of forces that surround us. And Super Galaxy is probably one of the first projects that Jason and I collaborated on. And it's a project that really kind of looked at the kind of hermetically sealed envelope of a building. In this case, we took Trump World Tower in New York, thinking of it as the kind of epitome of a monolithic structure in the city, sealed, air-conditioned, completely controlled. And what would actually happen if we were to explore the ability for that, let's say, these energies, these forces that surround our kind of, in this case, New York City to actually kind of infiltrate the building. What would happen if we blew, basically, essentially displaced or blew out 3 floors of Trump World Tower and actually kind of explored the possibility to exist out in the elements up there as a kind of on the 52nd floor of Trump Tower, and what would the opportunities be for a public space up there in the sky? A public space that is in sync with its surroundings, a public space that you could occupy these, what we call the kind of hotels, nomadic capsules up above. Oh, I have a mouse, so I can actually do this without waving my hands too much. So this kind of realm up above, which is more of a kind of habitation kind of area, versus a kind of public space up above in the sky. You can see the kind of typical floors essentially kind of striating the rest of the building. Structure continues to rise through, core continues to rise through, but you're essentially a kind of part of the elements here. You're seeing here a little bit of the, let's say, the kind of way that the geometry was generated, taking prevailing wind direction, and then also prevailing seasonal kind of seasonal wind direction and solar orientation to kind of determine the sag of these kind of bags up above, to be able to kind of determine the geometry of this kind of world of the hotel above. Here you're seeing the landscape that's created within that. Kind of inverted, essentially, kind of reflected ceiling plan on the right where the sky nests exist, and then a wind gallery below on the ground that collects water and kind of directs wind to move through it in a very, very specific way. And this was a project we did in 2003, 4 maybe, and it was one of the first. I kind of like showing this because it's before we did any of the interactive work that maybe you guys have seen on our website. And this was the kind of beginnings for us of really starting to explore ways in which maybe our surroundings don't necessarily need to be static. So this is completely speculative, where we were looking at maybe the ability of this kind of upper world to be calibrated depending on the next incoming weather pattern. So if wind was coming in from the north, then this kind of upper world would completely recalibrate in order to protect the environment of the weather garden below it. So this is something that we did primarily in drawings, and here you're seeing kind of one of many, let's say, kind of phasing drawings that we did. But then we were also interested in kind of looking at this kind of world sandwiched between, where maybe the ground or the kind of floor is actually one that maps the next incoming weather front as you're kind of occupying that landscape above. And here you're looking out of one of the capsules into the horizon. Shortly after that, so this, I guess, interest in the relationship of, in supergalaxy's case, the relationship of the building to its surrounding environment and how those two could actually exist in complete synchronicity is one that we have taken on in a series of, let's say, interactive installations. So you'll see a huge jump in scale in our work. You'll see speculative, large-scale, kind of big idea projects, and then you'll also see a series of installations, a series of prototypes, a series of projects that try to test some of these ideas of interactivity and kind of relationship of built artifacts to their surrounding environment. One of the things that we did a couple of years ago was a show in New York at the Van Allen Institute, which was called the Aurora Project. There was a number of parts to it. But the key kind of, let's say, agenda of the show was to really kind of figure out ways to represent things that are moving, things that are changing. It seems like a pretty, straightforward goal. How do you draw something that changes over time? Right? It's something that you probably have all been asked to do in your studio projects in the last couple of quarters, right? So in this case, we decided to take the polar ice cap as our case study, right? So this was at the time when a number of, let's say, studies were out there talking about the shrinking polar ice cap and how it was something that was happening at an ever-increasing rate. So we kind of went back historically and looked at ways in which the North Pole has been mapped, the way the North Pole has been drawn. So in the previous map, you can see terra incognita up above, unknown, just it's up there. We don't quite know its shape. It kind of looks like a cloud. It's up there. From, to Mercator's map on the left, where, it's kind of almost like an idealized understanding of what that world is up north. There's interesting kind of writings of, polar explorers, or the first polar explorers who went north and write about their experience of traveling one way in water and returning in ice, and the landscape completely changing in that time. So things that they recognize, like markers, geography, things that are located, are completely shift in that landscape. So how do we do that contemporaneously? This was something that was in the New York Times right around when we were doing this project, where, it's a GIF image, right? You show how the polar ice cap is shrinking, and it's a line, and you kind of follow that outline. But it's also understanding that there's a lot of other shifting territories and terrains in the North Pole, from the remote buoy sensors that are up there, which you can kind of maybe see on the left, so the left drawing is kind of mapping 3 days worth of buoy motion on the North Pole. So although it's ice, it moves quite a bit. On the right-hand side, you're seeing the edge of the ice shelf for the last 20 years. So that dotted line is the kind of seasonal transformation of that ice edge. To the left, where you're seeing the cache of the North Pole, gas versus oil, and how it actually turns out there is more gas than oil. On the right-hand side, you're seeing the domination patterns. You can kind of see, if you could read it, I apologize, where you're basically seeing the territorial fighting over that, the territory of the North Pole. So something that appears so fixed, or that we think changes only in terms of, the ice shelf, actually has all these kind of other landscapes and territories of volatility that are embedded within it. So we were interested in taking that information and actually kind of using that to generate essentially a piece of ice, or loft a piece of the Arctic, in this gallery in New York, to show this kind of very remote relationship to a very, very distant phenomenon. So the Aurora project essentially took the data sets of the Arctic and created this surface, this hovering surface of ice, and kind of suspended it in the middle of the gallery. The base that you're kind of seeing here are the series of structural buoys that are kind of located on the ground to suspend the surface. These were all individually cast. They had a varying ratio of white to gray, depending on the bathymetry of the Arctic. A series of soldered legs, oil rigs we called them for identifiable purposes, just because that's what they looked like, connected and kind of intermeshed the base, and then the kind of surface, the parametrically generated surface was lofted above that, perforated according to the age or the thinness of the ice. So depending on so X marks the North Pole. Sorry, I should have said that. So you're kind of standing in Russia, or the bottom of the page is Russia. The United States or Canada is to the north of the image. And that line, the blue line, basically takes you to the gallery in New York City where these were shown. So there was this kind of attempt at kind of taking a data set, using it to generate a surface. But then ultimately, the goal was to kind of rig the entire surface with a series of sensors that would actually track the gallery visitors and actually show the kind of volatility and ephemerality of this kind of world up there. So a series of LEDs were embedded in the surface, and then a series of cold cathode tubes, so the blue CRTs that you're seeing kind of hovering above, which would respond to the visitors as they approached it. So as you approached this installation, it would actually dim, shy away from you, and recede. So the lights would actually move away from you. So instead of it actually performing more for you, in your kind of attempt to get closer to it, you were actually killing the system and actually degrading the system that you were so attracted to kind of approaching. So here you're seeing this is one of the IR sensors, so there's LEDs embedded in this whole surface, and then the kind of auroras, that's the name of the project, these kind of suspended kind of CRTs up above. And this is really early on in our, let's say, Arduino life, where there is this kind of complete cluster of cabling kind of running through the entire project. So just to give you an idea of hopefully how far we've come, or not at all. But and here's a view back into the gallery space. jumping quite far ahead to a more recent project that really tried to take on this idea of mining a data set that surrounds you and actually kind of reprojecting or redirecting or kind of presenting that into the urban fabric in this case. So Data Grove was a project done for the 01 Art and Technology Biennial in San Jose, California. And the interest here, I mean, the call from the gallery, from the biennial was seeking Silicon Valley. So how do you actually, what is Silicon Valley? Where is Silicon Valley? It's more likely those images, right? You go take your picture next to the parking lot of Google or HP. You may be lucky to get a tour if you know someone and you get to eat at the Google cafeteria. But essentially, Silicon Valley is that. It's our kind of imagination of what Silicon Valley is. And San Jose as a city, for those of you who know it, relies on that image and that kind of vision to kind of propel it. What we were interested in was this version of, let's say, our surrounding environment. So how do you actually really understand a place? You understand it through the things that people are talking about in social media, primarily. And this is San Jose at a certain kind of time of day, a certain day of year, right? So how do you actually start harnessing this place and translating that back into the urban fabric? So we developed a series of kind of ways of actually harnessing, in this case, the top 4 is what you're seeing. We were harnessing the top 5. Unfortunately, the 5th one fell off the page, of things that are being talked about at that particular moment. So in this case, it's Wisconsin, Israel, now playing, and Easter. So those are the things that, for that particular moment, that instance that I took that snapshot to bring it to you today, that's basically what was kind of on people's minds for that particular instance. So Data Grove basically takes that information and retransmits it into the urban environment through a kind of web, a lattice of in this case, acrylic tube and steel conduit, a series of, we call them jellyfish. I think we need to find a better name for them. But a series of orbs, does that sound any better? Were nested within this lattice and transmitted back the things that you had heard about. So had you heard about Data Grove, or had you heard about technology, had you heard about Libya, or the next, or in most cases, depending on the time of day, the basketball scores, or whatever was being kind of discussed at the time, and it became a really interesting kind of let's say social experiment to a certain extent, because you would actually be able to track things at certain times of day. It was almost like a kind of urban well or water cooler where you'd kind of go to catch the latest news. And one of the things that I think this video probably captures some of it, if I can.
Have you heard about Data Grove by Future Cities Lab? There's a rumor about NASA Curiosity. Everybody's talking about the United Nations. Have you heard about Silicon Valley? Have you heard about X Factor? Have you heard about Silicon Valley?
So one of the really interesting things about this was not only the kind of process by which we actually ended up making the piece, but then also the reaction of the people that actually visited it. I was amazed at how many people were willing to talk to it. They were willing to basically respond to the prompt, have you heard about? They would be willing to basically look up things on the phone, because half the stuff I had never heard about. Maybe it's a generational thing, I don't know. But for certain times of day, I could understand. but let's say the kind of post-news to late night references that I had to look up myself. CDs, albums, things that were coming out, music that was, being released, or, when we were actually installing it and testing it, the Libya attacks took place, and suddenly the whole thing was all talking about this very, very remote, seemingly remote place from San Jose, Libya, politics. And then as the kind of night waned on, it turned into sports and music, right? So there's this kind of really interesting, let's say, patterns of San Jose, because it was a 5-mile radius. That's what it was capturing, which were kind of retransmitted in this way. Obviously, you can also tell that our work is really interested in just the way that we make things. As I said, make something, right? And in this case, the piece was made out of a series of acrylic tubing that was bent, and then metal conduit that was also bent using 2 different kinds of jigs. So a metal conduit jig versus an acrylic jig. So the acrylic we had to melt. So you're actually making a jig to melt plastic versus the metal conduit where you're making a jig to bend something over, right? The orbs, jellyfish orbs, were made by vacuumforming PETG, so vacuumforming plastic and embedding the electronics in it. And then the base was plywood and polypro ribs and skins. So here you're seeing the acrylic, the frosted acrylic tubing, and then the metal conduit coming together. These are 3 jigs per material. And through the kind of reuse of those 3 jigs and those 3 angles, we were actually able to kind of create the variety just through a recombination within the entire system. And I should also say that, as a design practice, we also have a fabrication shop that we were part practice, part fabrication shop. So all of these were actually done in-house. The electronics, the fabrication, the making, we do it all. How wise that is, we can talk about that extensively. But part of our kind of interest in this is actually learning through the making, learning through the materials that we actually use. So here you're seeing a couple of iterations of those orbs, embedding them with electronics, the vacuumforming of that outer shell. Here you're seeing the kind of sorting of the 3 different angles of the metal conduit. And then similarly here, the acrylic. Here is Jonathan bending that, heat bending essentially, that acrylic tubing. And here's a view through the installation, and then from above, just in terms of the kind of space that it actually created. The next kind of 3 projects are kind of really push the speculative side. So I kind of wanted to bring to you guys these 2 very, very different scales of work, but hopefully there's certain common denominators that you guys can see in some of the work that we do. So this is the Bay Area trilogy, or the Hydromax trilogy. It's 3 projects that we recently showed at the Yerba Buena Center for the Arts. Hydromax is one that we also did, earlier for the San Francisco Museum of Modern Art as part of their Utopian Impulse show. So with Hydromax and this kind of group of 3 projects, we were really interested in exploring the place that we had recently moved to, the Bay Area, and really trying to kind of explore the possibility and I guess the inevitability, though I guess in this context that word carries more, let's say, more weight to it, the inevitability of sea level rise for the Bay Area, and the kind of our ability to basically design for it, design with it in mind, respond to it. So those are the kind of ideas that were swirling in our head when we were asked to produce a project for a utopian show at the SF MoMA. And San Francisco, the Bay Area, for those of you who know it, seems like it's that kind of 68-degree, kind of 65, 68, kind of sunny, cloudy. But it's also characterized by extremes, extreme microclimates, extremely kind of specific neighborhood conditions that exist. And the Bay is actually a big part of that. When you're in San Francisco, you can barely see the water unless you make it to the edge. This idea of kind of understanding what that edge of the bay actually is, you never really see it as this condition of essentially a seashore unless you go to the beach. So for us, it was really kind of an interest in taking that whole area and understanding what the implications of sea level rise would be for the Bay Area. I feel this is the shaken and stirred slide. To the right, you're seeing the shaken. To the left, it's liquefaction, stirred. So fault lines on the right, liquefaction zones on the left. Just for your orientation, this little green dot is basically where the project is sited, but it's very close to the ferry building, so for those of you who know the kind of area. But it's the kind of liquefaction zone and the kind of fill zone that currently makes up San Francisco is pretty crazy. So property values in San Francisco have to do with that map on the left. If you look at that map and you correlate it with sunshine map of San Francisco, match those two and that's your value. Low liquefaction, high sunshine versus really foggy and on a liquefaction territory. So it's just kind of an interesting way of understanding, just kind of understanding the fabric of the city in those terms. So for us, this one you can't see at all, so I'll just skip it. But for us, it was also kind of an understanding that right now the way that San Francisco is dealing with its edge is through what you're seeing here, hard edge. A very kind of hard edge on the edge of the bay, keeping water out, keeping things at bay. Yes, the waves pretty frequently lap over that edge. It's kind of interesting. No one really thinks twice about it. But that edge is a very, very hard edge, and it's a protective edge. It's essentially a fortification mechanism. And what we were interested was really kind of what would actually happen if you let the water in? What would actually happen if you flooded San Francisco and understood that to a certain extent San Francisco will flood? So why not actually design and build for that in mind? I don't quite know if it's the tower with the museum and what was the typology that the gentleman was presenting earlier in the previous panel, the kind of escape route up into the sky. But in this case, it's more of a kind of understanding of our watery environment and actually trying to figure out ways to thrive in it. So how can we actually perform at 100%, thrive, and really want the water to come in, as opposed to constantly pushing it at bay, constantly trying to figure out ways to push it even further away from us. So Hydromax is obviously an entirely speculative project that was really kind of trying to push that thinking, push that envelope. And it proposed essentially a completely new system of piers on the edge of San Francisco. So what would happen if you actually extended streets out of San Francisco and back out into the water, reconnected San Francisco not as a street infrastructure, but actually as a water-based infrastructure, and really kind of embrace the possibility of reorienting San Francisco back to the bay. These piers are actually piers that deal with, obviously, transportation, produce moving in and out and through it. They're also productive machines. They're aquaponic farms. They harvest fog, collect water, depending on where they're located. And they also create public space. So for those of you who are familiar with San Francisco, this is Folsom Street. Klaus Oldenburg's Bow and Arrow is somewhere maybe here. The Ferry Building is just off to our page, but we're basically the Gap Building and the Banana Republic Building are right there. So we're talking about really kind of pushing the water right into the city and understanding what the opportunities for that could be. And here you're seeing an elevation, which I think this is probably easier. So the connection into the street, you're seeing a kind of new canopy system that starts occupying the current Embarcadero. Marshlands start occupying that edge once again. And then a completely other system embeds itself within the heart of this structure. So fog harvesting kind of feathers up above, collect moisture, condense it, store it in a series of water tanks that water a series of hydroponic farms up above. That water is then recirculated into a series of fish harvesting pods. That nitrate-rich water is recirculated back up and irrigates the gardens back again. Produce is harvested, fish. It's essentially an aquaponics loop. It's something it's a backyard system that currently exists In this case, we're proposing it as an urban system. So what would actually happen if we took something that exists at a much smaller scale and conceptualized it, thought about it as a much larger kind of system, and then ultimately all of that kind of gets channeled back out through the bay, through barges, ferries, flotillas that start kind of dotting the edge of San Francisco and connecting across the bay. So in some ways here you're seeing that kind of new, let's say, so if you were to take all the kind of dangerous zones outside of San Francisco, that's basically what you're left once you remove the liquefaction. And then you basically have this completely new network that starts dotting the bay and creating this new connection across the water. Biofuel production maybe would be something that these feathers up above could be doing instead of fog harvesting, let's say, on the kind of sunnier sides of town versus the foggier sides of town. So there'd be ways of actually kind of calibrating that system to very, very particular microclimates. And then just to kind of speculate, like what would that world internally, inside this thing be? Like what is public space when it's actually food production, maybe a kind of robotic hydroponics farm that actually kind of encapsulates the entire facade of the building? What happens when up above you have, let's say a ferry terminal, but one that is also producing food, capturing water, and actually kind of funneling people and produce through it. One of the things that we frequently do with a lot of the work that you'll see is that we also test things out, right? So we test things out in the physical. Sometimes we take a small piece and prototype it. In this case, we were actually asked to make an architectural scale model of this project. So so this is actually an interactive model of one of the Hydromax piers. So you're seeing kind of, three, I guess, as they kind of sprout out. And you're seeing the kind of fog feathers up above and the kind of multiple tiers. This was a model that we made, prototyped, and fabricated in our space from the customized electronics to the kind of assembly of the models, of the parts of the model. So you're seeing the models made out of these kind of, I believe there was like 7 or 8 of them, kind of modules that would essentially slot into one another and connect. And then parallel to that, the renderings, the drawings, the kind of all the components that need to kind of come together for something like that. Here you're seeing the kind of brains in the back that control the entire model. And just to give you an idea, I won't go through this whole thing, but somewhere here, just to give you an idea of the interactivity that we were able to kind of get. So there's a series of shape memory alloy motors embedded underneath this. So this person's waving, hitting an IR sensor. There's an SMA motor. So basically, shape memory alloy is a really interesting metal that when heated or when current passes through it, changes its composition. So if you think of like a bunch of squares stacked on top of one another, when current passes through, they turn. And then you have basically squares, but on end, which means a longer distance, right? So it's a very kind of simple mechanism. It's a silent mechanism that allows you to kind of create essentially a silent motor. So these fog harvesting feathers, in the setting of the SF MoMA, essentially reacted to the audience. So people surrounding it, people kind of moving around the model, triggering it, and actually kind of activating this canopy up above. So there's 3 parts to this kind of, let's say, Bay Area exploration. The Theater of Lost Species is probably the most dystopic of them all, so I'm warning you in advance. And it was a proposal. We're working on ways to actually make it reality, but for the time being, it's a proposal for an installation on the San Francisco waterfront. It was supposed to go up during the America's Cup, but it didn't transpire. So the Theater of Lost Species was really kind of interested in understanding this kind of obsession of cataloging, of capturing information from our surrounding environments, and also of the need to do that, right? So we need, so there's the seed bank in Svalbard, there's databases of, huge databases of information, of all the things that surround us. And we were really interested in kind of ways of capturing that, understanding that, and then kind of transmitting that back to our urban settings. So here you're seeing a kind of, I'm just giving you the kind of initial images and things that we were looking at, just to kind of talk through the process of thinking. But we were interested in, urban peep shows, camera obscuras, ways of kind of looking into another completely different world. And how do you actually start capturing information from your urban environment, potentially retransmitting it and kind of revealing it back into the space? So the Theater of Lost Species is essentially a data bank. It's an archive of species long lost, species long disappeared. So things that are extinct, that essentially exist within this virtual archive. So you could think of it as a virtual swimming pool that you would actually look in, trigger a sensor, and then that swarm would actually kind of move into your vision. It was originally seen, because it was part of a nonprofit organization that was more interested in kind of maritime environment. We're just thinking of this as a kind of swarming kind of school of fish that existed centuries ago, that would actually kind of come at you, and you'd actually be able to kind of understand them and see them and become familiar with, let's say, things that have long disappeared, things that are long extinct. So the entire installation was essentially made out of, was essentially proposed as a series of kind of modules that would kind of snap into place on this frame, encapsulating a series of screens that you'd actually be able to kind of look into at every kind of single moment. And then, that world of, in this case, aqueous marine life, but could be anything else, depending on the data set that we were kind of working on, from pterodactyls to the latest fossil that disappeared, are actually kind of part of this data bank. And here's a view kind of it in its, let's say, urban setting, people looking into it. We had visions of this thing, if you were to think of it at a completely different scale, roaming the land, scanning for the next species that's about to disappear, cataloging it, and then kind of continuing its kind of way through the landscape. But in this case, we're kind of thinking of it as something that is, more scalable in terms of its, let's say, opportunities. And here's a view of it, potentially a scalar. This is kind of one of those projects where we kind of really explored, on the one hand, okay, how do we make it real, but then also how do we push the more speculative side of it in maybe a more deliberate kind of way. So we made a physical model of it as part of of the show at the Yerba Buena Center for the Arts. So here you're seeing a couple of the prototypes in the back, and then a couple of the final pieces, the green pieces, which are 3D printed pieces that sit on a acrylic frame. That frame then gets kind of rested on these kind of series of three legs that actually support the theater. So here you're able to see this kind of model. One of the things that we're interested in is, especially when we work with these, let's say, digital fabrication techniques, is how do you actually, 3D printing is awesome. It's interesting. It's exciting. But it's very easy to 3D print this whole thing like that as one piece, right? So how do you actually start maybe understanding the way that certain materials come together, the way that certain things need to be transparent, certain things need to be solid? How do you understand the way that things connect, in which case you're not really, in this case, we could have 3D printed the whole thing and just plonked it on a base and lit it from below, but we were really interested in understanding that kind of hollow quality of that interior world. So having that seam, that acrylic seam that actually kind of locks all the pieces together, became really, really critical and important, as well as the distance between, let's say, the kind of viewing portal and the kind of the surface behind it. So, and here you can see an image of part of our shop. You can see the mill in the back, the laser cutting room, and our kind of fabrication space. Here's the cleaner version of that, the model in its white base with the white wall in the gallery, and G and Rip, who work with us in our office, posing. You can probably start seeing a kind of growing pattern of the same people in all the pictures. It's all of us rotating from one to the next. And here's a view of the the Theater of Lost Species, its drawings, and then Hydromax, the model was right behind there. And the kind of last project that I'd like to kind of talk about a little bit, and then I'd love to have questions from you guys and a conversation, is Hydrospan. So Hydrospan is the kind of third piece in this show. So if Hydrospan's behind us in the picture. These kind of three kind of existed as their own little constellation. So Hydrospan was a project that took another, let's say, canonical, iconic place in the Bay Area, so the Bay Bridge. This was all taking place at the same time as the kind of Oakland span of the Bay Bridge was essentially being decommissioned. The new bridge was opening up at the same time. That old span of the bridge has already been sold for scraps, metal scraps. If you cross the Bay Bridge in the next couple of months, you'll see big parts of it just taken away. The thing is like it's like the completely perforated bridge. It's pretty crazy. So, but that idea that, you can essentially build infrastructure extremely kind of costly and expensive, and then basically take it away. The steel has been sold back to China. China is supplied the steel that built the new bridge. So there's this kind of really interesting kind of economy of like old disused infrastructure, and how that could potentially, in our case, be a really kind of amazing opportunity to kind of hook on, capture. So the San Francisco span of the Bay Bridge is what you're seeing here, and we were kind of interested in kind of proposing and kind of visioning a kind of next version for the San Francisco span of the Oakland Bay Bridge. And here you're seeing kind of the current use of it, right? But should this bridge, which it's slated to at a certain kind of point in time, actually become not up to code, disused, or no longer useful, what would actually be its next life? Instead of scrapping it and selling it for parts, could you actually reuse it? Could you actually kind of use it as this kind of amazing place to occupy? So parallel to this, we obviously have an interest in kind of science fiction writing, and movies. William Gibson's Bridge Trilogy, 3 books written about the Bay Bridge and this kind of crazy/amazing colony of people who actually occupy the Bay Bridge and use the Bay Bridge as their, let's say, headquarters, or how should I say, of their new vision of the world. Obviously, kind of, was super interesting to us. But parallel to that, at the time, it's when the Google barge was out and no one quite knew what it was doing, and there was conversations about, Larry Page wanting to set aside a part of the world for unregulated experimentation, or potentially Silicon Valley seceding and actually kind of becoming its own kind of territory. So there's an incredible, political, financial, economic pressure to the Bay Area. So we were kind of taking those kind of ideas and those, let's say, that atmosphere that was kind of going on at that time as the Bay Bridge was being decommissioned, Google was growing, the Google bus conversations were happening, and really kind of starting to maybe think, well, maybe Silicon Valley does secede. Maybe their campus actually becomes even more gated. Maybe they actually, the next Google 2.0 campus is actually on the Bay Bridge. It becomes its own kind of world, its own colony that uses the structure of the Bay Bridge, which would actually serve as, let's say, the structure for, on the one hand, above, a new park that would exist, up above that would be tended by those same robots that occupy Hydromax that's way back here in the distance. So as you can see, we're slowly making our own world and losing ourselves in it. So up above, you're seeing this kind of new public Highline-esque world. Hanging and suspended from it, a series of, up above you have a series of kind of water harvesting and water catching kind of cisterns that would actually filter the water through these kind of lower pods that would actually kind of drop back down into the bay and maybe clean the water of the bay, or maybe just kind of provide for a place for people to dock and access this kind of new colony up above. So this becomes the new Google complex, the new Google office, part corporation, part water harvesting, water cleaning and kind of filtering device, and also part public space within the just off the edge of San Francisco. So to test that out again, so you follow the pattern now, we kind of come up with these things, and then we're like, okay, well, how could you make it? How could you make it a scale model of it? How could you actually try this out? And we see that as just a way of slowly kind of trying to figure out the scalar shifts that this kind of work needs to kind of go through. So here you're seeing a 40-foot model of the San Francisco span of the Bay Bridge. Up above, that's that kind of public or the lower deck. So if you're heading to Oakland, you'd be driving on that, or coming back to San Francisco, you'd be on the upper deck. Those two decks are basically given up to public space, garden, green, water harvesting, food growing. Below, you're seeing these kind of occupation pods, or these kind of suspended gardens. And then down below on the water, the kind of more watery environment kind of suspended below it. So each one of these pieces was made by kind of vacuforming, making a series of molds and vacuforming a series of, in this case, PETG and acrylic. I think I have some, yeah. So here you can see, like as we're assembling it, down the middle of the model. So that's that kind of world up above with these kind of water kind of filled sacks that are actually kind of collecting water up above that then kind of get filtered through these fog harvesting ribbons back into these pods. Here's a view of I can't quite call it manufacturing, but it seems like it in terms of the kind of repetitive process that we actually had to go through, because there's only a series of modules. Although it appears so varied, there's only a discrete kind of selection of different kinds of things that had to be vacuformed and assembled. And here you're seeing the kind of the pieces that made that the upper deck, basically, of the Bay Bridge. It was made in a modular way so that it could travel and assemble on site just by kind of clipping into the larger frame of the Bay Bridge. And for those of you who know the Yerba Buena Center for the Arts, it's a pretty interesting building right downtown. The Libeskind Jewish Museum is right across the street. And it's this kind of really interesting condition where there's the kind of pop-out window back out into the city. It's a really long, narrow space that they never use for exhibitions because it never gives them enough distance to put artwork in it. So in this case, we kind of took advantage of that space and basically kind of spanned that 40-foot-long model in that kind of, essentially a kind of bay window back out into the city. The entire model kind of pulsed according to the kind of amount of people kind of moving through it. So it also tried to kind of capture some of the energy of the space of the gallery itself. And here's a kind of view in it with the kind of one of the towers and then the kind of suspended pieces. So in conclusion, I'll just leave you with that one. But in conclusion, I think one of the things that I kind of wanted to bring up relative to the prompt of the conference or of this kind of gathering is one of the things that I think was written in your initial statement, which is that the built and natural world, it's the assumption that they have been in conflict, right? That the built and natural world are in this kind of constant battle. And that, our kind of interest in sustainability, environmental movement, that those are all about kind of figuring out ways to usually let nature, the natural world, kind of win within that battle, or at least kind of find a compromise between the two. So what I would actually kind of argue is that doesn't mean that nature always maybe has to win in this world. That I presented to you today. I think we need to find alternative forms and alternative modes of practice, design practice. You're all being trained as architects. You're all being trained as designers. You're all being trained to make things, right? Make something. And I think that the challenge for you is how do you continue to make things and how do you continue to make things well in a world that has that conflict in it, right? So how do you as designers thrive in the new world that you yourselves are crafting every day. Thank you very much. Yeah, whatever you want.
We'd like to take about 10 minutes for Q&A and then take a 3 or so minute break. And then start the panel discussion that's supposed to start around now. So does anybody have any questions? Okay.
Do you consider the work utopian?
Could you speak up a little bit so the whole audience hears?
Do you consider the work really utopian? And if you had a choice, would you build larger installations or smaller buildings?
I would say the agenda and the ideas appear utopian. For us, I wouldn't say that they are utopian. For us, we see it as the future. I think in terms, and one of the things that you'll notice in pretty much, especially, what I call the speculative projects is that a lot of them have a hook in reality, right? There's something in them that actually, whether it's a specific building system, an aquaponic system, a kind of technology, a technique that actually has a kind of hook in reality. So so to a certain extent, I would say they're utopian maybe in terms of their, let's say, extent, but maybe not in terms of their technologies and their techniques. Now, if we had a choice, I don't think any architect would tell you that they never wanted to do anything bigger. But one of the things that we've realized is that also where we've started to kind of figure out where our strengths are. And one of the things that we've recently been doing is actually kind of being parts of, being let's say, collaborators or consultants within larger teams of landscape architects, urban planners, architect teams, where we're kind of coming in and providing, let's say, consulting makes it sound really corporate, but ideas about, interactivity, ideas about urban activation, using public space in, let's say, kind of alternative ways, finding ways to really kind of embed technology within our environment. So I would say we're not building the buildings, we're actually maybe shaping the spaces between the buildings or contributing at that level, as well as, let's say, the kind of carving out of territories for possible urban occupation. So I kind of answered that, I think. 1, 2, 3.
I just have kind of a pointed question. You showed the fabrication for data growth, but
yes.
How did you envision that form to begin with?
So we usually think through our projects, usually through physical model. So I know it appears like it's all, computer driven and then voila. We usually kind of oscillate between like making a digital model and then making a physical model of it. So I could have shown this, but for example, our first models of data growth were just kind of laser cut triangles. So we were just kind of trying to figure out how to. We had this idea of a web that had these things caught in it, kind of like flies in a spider's web. So we were kind of thinking of it more as a kind of network of things that had certain things kind of embedded within it. So we started off by making maybe, for us, laser cut models are very quick. But they're also two-dimensional, right? So we were kind of restricted with that. So once we kind of went through a couple of iterations of physical models, we plug it back into the computer, give thickness to the material, and then start moving to maybe a more tube-like material. And then just using electrical. Well, this isn't the right room to point to electrical conduit, but usually it's above you in most lecture theaters that I've been in, but not this one. This is really nice. So that's we use a pretty typical material that you can bend really easily. Acrylic was a little more finicky because it becomes really brittle once it kind of once you melt it and you reheat it. So that was kind of like a one-shot jig thing that we had to do for that. And there's one up front here as well after. Whoever's the mic.
Kind of expanding on the materials, you mentioned thinking about those. I'm wondering, with larger applications, what you're using PETG plastics here.
What could those be?
Yeah, what would those be for a dystopic or utopian society?
Well, I mean, one of the things that we've been asked, I was talking about the kinds of projects, let's say the more real projects that we've been involved in. We're in we've been in the process of designing a kind of larger scale canopy, and in that case, we're actually kind of working with a glue lamp, essentially, to actually make a kind of much more kind of intricate surface, kind of like, you've probably seen Jürgen Meyer H's kind of work, right? So really, or the urban parasol stuff, right? So there's ways that things are actually able to scale up. For us, the kind of tricky thing when we do that is also kind of figuring out how to scale up the technology. So fabrication is one thing, right? But suddenly when you have inputs from not just 5 places, but 5,000, that becomes a much more complex kind of world to actually kind of be dealing with. So for us, the scaling up doesn't only happen in, let's say, the fabrication material side, but then also the kind of technology side of things.
So kind of talking about technology, it seems that in a lot of your work, you're using a lot of today's technology. How do you ask yourself tons of provide arms? And how does your work presuppose the flexibility for future technologies? No more KUKA, no more PGH flying drones that track fibers and untethered fibers, etc. Mm-hmm.
I mean, that's a really, really, really interesting question, because I think in some ways our, let's say, hook in reality has been the technology. Like, we're basically saying, okay, we're co-opting technology that is current but not in architecture, potentially, though one would argue, CCA is also about to get its next robotic arm, right? So it's something that's percolating the schools. It's not actually percolating into the industry or into the actual practice. So we see it as a way of maybe pushing that realm a little bit further rather than, let's say, the kind of academic world in that sense. So I think the kind of challenge, I think, is an interesting one that you bring up, because on the one hand, in our case, we use the technology as the hook into reality, but if that weren't the case, then it would be completely fictitious, which maybe isn't too bad. So, I mean, I think that's a good point. I have to think about that a little bit more. Because I think if you take the technology out of it for the work that I just showed you, it becomes really hard to figure out, like, what separates it from science fiction. And that's a line that we toe very closely. And we use technology as the thing to ground us in reality, although it's not a technology that is architectural, like in today's day and age, right? So in some ways, like, I think if we let go of technology, then we're completely in the realm of science fiction, which may not be a bad thing, and I wouldn't necessarily be against it, but...
Last question from the audience.
Hey.
Talk about place for a moment, if you would. San Francisco is clearly your home. You teach there. You have your studio, all of that stuff, and you're learning quite a bit about the biome that is that place. But is there enough of an audience there for you? Are you developing a constituency? Would your work go better elsewhere? Antarctica, Kosovo, London? How are you feeling about being in San Francisco?
Okay, we just had this conversation over dinner, actually. So we moved to San Francisco 5 years ago from East Coast. I taught at University of Michigan, University of Virginia, East Coast school education, as far as I'm concerned. And we moved to San Francisco, and the first thing that our friends said was, "Why are you going to San Francisco? Why are you guys not moving to Los Angeles?" Because that's where, the kind of work that you do, that's where you'll find your people. And I think for us, moving to San Francisco has been really, really fantastic. It's more conservative than Los Angeles, more conservative than a lot of other cities, but I also think it's also a city that's changing, and it's changing really, really rapidly. We were just talking a while ago about this, the amount of buildings that are slated to go up in the next couple of years in San Francisco. Snaheta, Diller Scofidio, OMA, Bjark Ingels, field operations. So the city has slowly somehow come out of, someone asked you to tell them what the architecture tour is in San Francisco right now, and there's certain really amazing things, but nothing like, let's say, the other cities that San Francisco would kind of counter itself to. So parallel to that, let's say kind of what we saw as the kind of ascent of the city, I think it's also our ability to be close to the technology, close to the people who are actually making the technology, talking about the technology. We found a lot of our audience, I would say, isn't as architectural as it is public art, technology, hacking, Silicon Valley, going to presenting our work basically to the tech world. And then really kind of working through maybe more the art world to get our installations and our kind of work prototyped and built. Nonetheless, we both teach in architecture schools. We're part of the academic community as well. And CCA is a really fantastic place where those worlds where you can kind of, it's a NAB accredited degree. It's a professional degree. You can get that degree, but then also kind of be exposed to this kind of other layer, which is very much the kind of Bay Area. So we're willing to stick it out, and we want to stick it out. And neither of us is from San Francisco or California. I'm from Greece. So San Francisco is very far away from what I would call home. But somehow in San Francisco, there's definitely a kind of energy that we would like to kind of tap into for the next couple of years.
Thank you very much.
Thanks.